for real recording. So rational expressions are written in the form P over Q. Well, P and Q are both polynomials and Q cannot be zero. P is the numerator, Q is the denominator, right? If Q, or if your denominator is zero, that is an undefined expression. You can't put it into your calculator, right? We've done that a few times. 1 over 0 is an error in your calculator. You cannot divide by 0. So when they ask you on My Math Lab, what is undefined, it's anything over 0. Undefined. Just like when we were talking about slope, that's an undefined slope, right? If your x is, because it's y over x is slope. So if your x is 0, if you don't move on the x, it's called undefined. Something else that will be on My Math Lab that I've talked about a couple times that I don't know if I'm explicitly teaching well enough is negative a over b, or anything, right? Negative something over something is the same as negative a over positive b, which is the same as a over negative b. Okay, it doesn't matter where you put that minus sign, because a rational expression or a fraction is division. So we're saying it's a negative positive divided by positive, right? Which is the same as, so negative 1/2 is negative 0.5. Negative 1/2 completely, right, is also negative 0.5, and 1 over, 1 over a negative 2 is also negative 0.5. So if it's over 0, it's undefined. You can put the minus sign here. You can put the minus sign with the numerator, or you can put the minus sign with the terms of the denominator. Does not matter. Those all equal the same. Some examples of rational expressions are these 3 fractions in which the numerator and the denominator are both polynomials, right? So this is a trinomial divided by a binomial, binomial divided by a trinomial, monomial divided by a monomial. They are all polynomials. There's not a 0 in your denominator. Good. If there's a 0 in your numerator, you're just going to get 0 as your answer. So that's not frequently seen either. The first thing I'm going to do is talk about the domain. Remember, domain means your x values, right? So it's all possible x values or inputs. So I choose the x values, I choose the domains, I put them into the function gives me an output or a range or a y value, right? So there are 2 what we call limits on the domain. The 2 limits on the domain is that a 0 in the denominator is undefined, just like we talked about on the last page. Good. And then a negative under a radical, under an even radical, is no solution, or it's an imaginary number, which we're not dealing with in this. Yeah, we're not dealing with in this course. You will deal with it soon, but this is not going to give you a solution. This is not going to give you a solution. So we call these limits on the domain. Good. So you are looking for, if they're saying find the domain, the answer is often all real numbers. Okay. And we write that as x such that x is all real numbers. You can write it like that, or x is from negative infinity to infinity. So those are 2 different ways to write the domain, but you're just basically saying it's all of the numbers. All right. However, if you encounter this situation, if you encounter, let's see, if you have a variable, here's a better way to say it. If you have a variable under the division bar, or if you have a variable inside the radical, you now need to make sure that the variable under the denominator or in the denominator cannot be 0. You want to make sure that the variable under the radical cannot be negative. So those are the limits on your domain. Okay. Let's look at the first one. 8x to the third plus 7x squared plus 20. You're looking at the denominator because there are no radicals. So there's a denominator because there's a fraction. However, there is no variable in the denominator. There is no x in the denominator. There's nowhere to put an x value into the denominator. The denominator will always be 3. No matter what x value I put in between negative infinity and infinity, any real number for x I put in to this function, I will always have 3 under the division bar, right, as my denominator. So the domain is all real numbers. The x value does not change the 3. Good. So this one's going to be negative infinity to infinity, or x such that x is, you can say equals or is all real numbers. We'll just make that a big number sign. Here, however, we do have an x in the denominator, okay? When I see an x in the denominator, I say I cannot allow this denominator to equal 0. That's the only limit on this domain, okay? There is a value that x cannot be. X is all real numbers, x equals all real numbers. Here, x is not a number. So our domain is x such that x cannot be something. When x is that something, we get a 0 in the denominator. I think it's kind of evident to see what it is, but the general rule is take the denominator, take that denominator, set it equal to 0. Good. Set the denominator equal to 0. Solve for x. Good. So the first step would be x minus 1 is 0. Then we're going to solve it for x. Add 1, x is 1. And then exclude that number. And it might be more than one number, so you can say exclude that answer. Okay, so we take the entire denominator that we're worried about becoming undefined, set it equal to 0 because 0 is what we don't want here. Find what x would make that equal 0, and then say that it is not that number. You're done. Okay, that one was fairly simple. When x is 1, I'm going to get a 0 under the division bar. So I'm going to say the domain is all real numbers except that x cannot be 1. Good. If I wanted to do it in this fashion, I would call it, it's a little bit more complicated, but it's from negative infinity through 1, but excluding 1, and it might be a comma, they might ask for a u, 1 to positive infinity. Good. All right, same here. Here we have a quadratic equation in our denominator. There's still no radical, but we cannot put any x's here that would make x squared minus 2x minus 15 equal 0. So basically, we just need to find the values of x for x squared minus 2x minus 15. All right, so this is where at the very beginning I said we're going to use our factoring skills from the previous unit. We're going to take x squared minus 2x minus 15. We're going to factor it to solve for x. Okay, so and it's okay if you get two answers. X can't be 1 and x can't be 0, for example. Good. So if we remember, we do x squared minus 2x minus 15. If I want to factor it, I call this term a, right? So a is 1, b is -2, and c is -15, right? I want it to, if I'm just factoring it, I'm going to end up with, because a is 1, I can just put an x here and an x here. I want these two terms to multiply to equal c. And I want them to add to equal b, which means they need to multiply to -15, add to -2, right? What are my factors of -15 that could add to -2? Well, it could be +1 and -15. It could be, I can't divide it by 2, I can divide it by 3. -15 divided by 3 gives me a -5. -5 and 3 combined does give me -2. So I'm going to choose +3, -5. So here we have x squared minus 2x minus 15 factors to x plus 3 and x minus 5. Good. Now, what did we say? We said if we have a denominator with x's in the denominator, we set the denominator equal to 0. So you can do it here. You can say x squared minus 2x minus 15 equals 0. But to solve that for x, we decided that the most familiar way to us to do that is to factor it, right? So if x squared minus 2x minus 15 equals 0, then x plus 3 times x minus 5 is also going to equal 0. Solve for x. Remember the rule for factors, which is that if this term times this term equals 0, that means that we can say x plus 3 is 0 or x minus 5 is 0. So there are two possible answers that will give us 0 when we put them in for x. We can solve that now. X equals -3. If I solve this one, I get x is a +5. Good. So here, x squared minus 2x minus 15, the two x values I get when I set it equal to 0 are -3 and 5. You can check that by saying -3 squared. So I'm just taking that -3 and I'm putting it in here. -3 squared minus 2 times -3 minus 15 is 0. And then we can try it with 5. So here's 5 squared minus 2 times 5 minus 15. And I also get 0. So I can check to make sure that's true. And 0 is what we don't want in the denominator. So we're just going to say the the domain is x such that x cannot be -3 or 5. Good. All right. Now we're moving. So that is domain. Anytime they ask for the domain of a rational function, they're saying, since it's a rational function, that means it's going to be a division problem, right? It's going to be this divided by this term divided by, this polynomial divided by this polynomial. So you want to make sure there's no x's in the bottom of your fraction in your domain. And if there is, take that, set it equal to 0, solve it for x, and say that that is outside the domain. The domain is everything except what makes this 0. The domain is everything except what makes this 0. There's nothing that can turn a 3 into a 0, so we just say it's all real numbers. This one is a trinomial, and to find, so we're still solving for x, we're still setting it equal to 0. And then to solve it for x, we factored it. We got x is -3 and x is 5, and we're going to exclude that answer. So just like we said, x minus 1 equals 0, so x cannot be 1. Here we said x squared minus 2x minus 15 equals 0 becomes x equals -3 and x equals 5, so x cannot be -3 and x cannot be 5. All right, on to simplifying. Simplifying a rational expression means writing it in the lowest terms or the simplest form. Good. So when a rational expression is simplified, it means that P and Q do not have any common factors. The only numbers that you can divide both P and Q by, P divided by 1 and Q divided by 1. Those are the only ones that you can divide it by. If you can divide them both by the number 2, they're not in simplest form, okay? So to put it into simplest form or lowest terms, you want to factor the numerator and factor the denominator, okay? Then cancel any factors that are the same in or common to the numerator and the denominator, right? So we have PR divided by QR. The factors of P and R are P times R. Q and R is Q times R. So we separate those out. P times R, Q times R, they both have R as a common factor, right? Factors that are the same or common factors. In this example, it would be the common factor R, right? So we cancel R and we just say P divided by Q. All right, how about an example, right? If I have the number 24 and I'm dividing it by 8, do you know what that is? 24 divided by 8 is 3, okay? But if it was, because it's a rational expression, I want to explain lowest terms or simplest form by taking it just a step further, okay? So PR, we broke into P times R, right? 24, we can break that into factors 24 and 1, but that one's not helpful, right? Because 1 doesn't matter. 24 and 1, 12 and 2, 3 and 8, right? And when I hear 3 and 8, I see, oh, there's an 8 here. So 24 is the same as the factors 3 and 8. 8 is the same as the factors 8 and 1, right? 24 is 3 times 8, 8 is 8 times 1. We can cancel the 8 because it's common to the numerator and the denominator, and we just get the number 3 over the number 1. 3 divided by 1 is 1, right? So you can do it with any number. You can do it with, let's see. Let's do 12 and 18, okay? And you can start wherever you want. You can say, well, I can divide them both by 2, so you can take out the 2 if you want, or you can say that I know 18 is 6 and 3, right? I know that 12 is 6 and 2. They both have 6 in common, so I can cancel out that 6, and 12 over 18 is the same as 2 over 3. You can check it in your calculator. 12 divided by 18, 2 divided by 3. Good. So that's what they mean when they say cancel factors that are the same. So you're going to have two numbers, factor them out, cancel factors that are the same, make sure that the fraction that you have, there is no number that you can continue dividing it, because I could also take 12 and 18 and I could say 12 is I could say 12 is 3 and 4, right? And I could say 18 is 3 and 6, canceling out the 3. That's now 4 6. And I can further factor 4 and 6. So 4 is 2 times 2. 6 is 3 times 2. Cancel out those 2's and I still get 2/3. Good. So if you found one factor, that doesn't mean you're done. Look at that number again. Make sure there are no common factors to 4 and 6 to your next answer. And keep going until there are no common factors between 2 and 3 except the number 1, right? Okay. Let's try it with polynomials. Good. All right. So I can't factor x squared plus 3x minus 4 and x squared minus x minus 20, because to cancel something out, it has to be multiplied. It has to be a true factor, right? The reason we can cancel out the 3's is the 3's are being multiplied by the 4 or the 6. Here, the 6 is being multiplied by the 2 and by the 3. You definitely cannot say 2 plus 3 over 2 plus 4 is 3/4, right? That is not true. You can't cancel it if they're being added or subtracted. You can only cancel if they're being multiplied, because 2 plus 3 we know is 5, right? And 2 plus 4 is 6. 5 6 is the same as 3/4. You will see it is not. 5 divided by 6. Oops, sorry. 5 divided by 6. 3 divided by 4. Those aren't going to give you the same number. So it only works if there are no signs between the terms, right? You're just multiplying, okay? If it was 2 plus 3 times A and 2 plus 3 times B, then you can factor out the 2 plus 3, right? Because we've done that a lot with factoring by grouping. So it's fine to factor out a plus side, but it has to be the exact same entire binomial on the top and the bottom. And the reason you can factor it out is because it's being multiplied, not added or subtracted. Okay. And I know that's a lot right now. A lot of detail. So make sure you're only factoring out things that multiply. Therefore, when we look at x squared plus 3x minus 4 over x squared minus x minus 20, we can't just say the x squareds cancel out, because those are being added or being combined with other things. So what we want to do first when you have something like this is factor, just like we factored up here. Okay, we said x squared minus 2x minus 15 changes to x plus 3 times x minus 5. All right, so that's what we're going to do with x squared plus 3x minus 4. Go ahead, if you want to go ahead of me, try to factor this. Feel free. So x squared plus 3x minus 4. The a's are 1, so we're just going to have x and x. We need it to multiply to equal -4. And we need it to add to equal +3. So if it's going to multiply to equal -4 and add to equal +3, I'm going to say it's a -1 and a +4. So that's going to be x minus 1, x plus 4. Good. X squared minus x minus 20. Same thing, we're going to want to multiply to equal a -20. and we're going to want it to add to equal a -1. Interesting. So I know that because the a is a 1, I can say it's x plus or minus something times x plus or minus something. It's going to multiply to a -20 and add to a -1. So that means I want of my factor pairs, I want my bigger number to be the negative, right? So I could say 1 and -20, but that won't combine to -1. 2 and -10, that won't combine to a -1. 4 and -5. If I combine those, I get a -1. If I multiply them, I get a -20. So I'm going to call this x plus 4, x minus 5. Good. So the first thing we do is factor. And then once we have the factored form of your numerator and your denominator, cancel what are called like terms. Okay, so we're just going back to factoring. Now we're adding the step of simplifying a fraction, because after we factor it, we have something that's the same value, but in lowest terms, okay? So we're using the factoring skills from last unit, taking them, applying them to fraction. All right. All right, this one's interesting. 7 minus y over y minus 7. So obviously we don't need to necessarily factor them, right? But I do want to know, does 7 minus y equal y minus 7? Are those common factors? Are they exactly the same? So if I look at 7 minus y over y minus 7, I can't really tell. What I'm gonna do, this has the y as the leading term. This has the 7 as the leading term. I'm going to take my y with its sign, and I'm going to put it in front of the 7 so that I can better try to figure out if those are the same. So now instead of 7 minus y, I flipped them around, and now it's negative y plus 7. And here it's y minus 7. That's a negative, well, that's a positive. That's a positive, well, that's a negative. Otherwise, they're the same term, right? So when they are that close, they're not exactly the same, but they're that close, try multiplying one side by a -1. So negative y plus 7 times -1. Good. So -1 times -y becomes a positive y. -1 times 7 becomes a -7. Y minus 7. So what I'm saying is that y minus 7 times -1 is the same as, is the same as -y plus 7. You see it? That is exactly the same as that. So I kind of just factored out a -1. So now that becomes -1 times the quantity y minus 7 over y minus 7. And what can I cancel? I can cancel the y minus 7. And what I get is a -1. So if they're very, very similar, you might be able to multiply either the top or the bottom by a -1, factor out the -1 so that you have the same terms on exact same polynomial on the top and on the bottom, cancel them, and you're just left with a -1. And again, it doesn't matter if I do it on the top or on the bottom. The -1 on the top is the same value as a -1 on the bottom, because when that completely cancels, it's left as a 1, right? -1 divided by 1 is the same as 1 divided by -1. Good. All right. I would not worry about this one. Let's ignore that. 2y squared plus 2 divided by y cubed minus 5y squared plus y minus 5. Good. All right. What can I factor out of the first one? 2y squared plus 2. I can factor out a 2, right? 2y squared divided by 2 is just y squared. 2 divided by 2 is just 1. So when I factor the top of this fraction, all I get is 2y squared plus 2 becomes 2 times the quantity y squared plus 1. I have 4 terms on the bottom. Anytime you have 4 terms and you can't divide anything out and you can't combine like terms, you want to think factoring by grouping, okay? Think factoring by grouping. When I factor by grouping, well, let's just make sure. Y cubed negative 5y squared plus y minus 5. So there are no common factors, right? Ignore this. Let's just factor those two and come back and factor these two, which don't factor, but we can do a 1, right? Y cubed minus 5y squared. I can factor out the y squared. Yeah. So that leaves me with y squared. Y cubed divided by y squared is y. Negative 5 y cubed, or sorry, y squared divided by y squared is just negative 5. So that's that side in factored form. Then we have plus y minus 5. It's a positive, so I'm going to bring down the positive. Keep this number a positive. Y and a negative 5 don't have any common factors, so I'm just going to say plus 1, right? Y divided by 1 is y. Negative 5 divided by 1 is a negative 5. So I've factored them by grouping, but I do have the common factor of y minus 5. And I'm going to multiply that by y squared plus 1. Good. So in factored form, y cubed minus 5y squared plus y minus 5 becomes y minus 5 times y squared plus 1. Good. So again, you're just using what you already know. If I looked at this, I didn't know it was part of a fraction, and they just asked me to simplify it, it's just going to be, what can I factor? Okay. I can factor out a 2. Down here, I have 4 terms, no common denominators, no like terms to combine. I'm going to factor by grouping. I'm going to end up with this, right? This is familiar. Now the step is cancel out the y squared plus 1. Good. So the final answer for 2y squared plus 2 over y cubed minus 5y squared plus y minus 5 is 2 over y minus 5. So that is what it means to simplify, okay? Take out anything that is common to the top and the bottom, but just take it out very carefully following the rules. So we've gotten through finding the domain and simplifying, which are very, very difficult. Good job. We're going to go on to multiplying rational expression, okay? Multiplying rational expression is just straight across, just like all other fractions when the fractions were just numbered. So P over Q times R over S is the same as P times R is PR, Q times S is QS, okay? This can't be 0 and this can't be 0. This can't be 0 because the only way for this to be 0 is if one of these is 0. Sorry, I'm losing my voice. 1 second. Right. In order to to multiply rational expressions, you want to factor the numerator and factor the denominator, okay? Because we're not going to get if we're trying to simplify this, you can take m minus m squared, so m minus n times m minus n times m, and write all that out here, and then multiply m plus n in parentheses times m squared minus mn. But it would be better to factor whatever you can before you do the multiplication, okay? That's why it says factor each numerator and denominator to use the rule and multiply numerators and denominators. And then simplify after you multiply to cancel the common factors in the numerator and the denominator, okay? So factor the numerator, factor the denominator, multiply, factor again to make sure you have it in simplest form. Good. For example, if you had the number 5/8 times 24/35, right? We could just say 5 times 24 is what? 90. No, 5 times 24 is 120. And 35 times 8 is 280, right? And then we simplify that, right? By factoring that out. But those are really big numbers. It's obviously going to be more difficult to factor a really big number than to wait and say, what are the factors of 24? What are the factors of 35? Can I cancel anything at that point, right? So instead of that, when you are at the stage of 5/8 times 24/35, think about, well, 5 and 8. 5, I guess, could be, no, 5 has no common factors. 8 could be 4 and 2. But we're going to take 24. 24 is 3 times 8, right? 35 is 5 times 7, right? So that way, if I'm thinking about what I'm multiplying it by, 5 goes into 35, or sorry, 35 goes into 5, 24 goes into 8, right? 8 goes into 24. Sorry, I'm saying it backwards. All right. 5 goes into 35, 8 goes into 24. So what I have is 5 times 3 times 8 over 8 times 5 times 7. I can cancel those. And I'm left with 3/7 instead of 120/280. Good. Here, what we want to do is take this from standard form to factored form in order to cancel factors. Just like this is standard form, this is factored form. Standard form, factored form. Good. In order to cancel factors. So m minus n squared is just the quantity m minus n squared times m. So if I wrote that all out, that would be m minus n times m minus n times m, right? Down here we have m plus n, m squared minus m times n. That one I can factor, right? Just like I factored this to look like these two, right? M minus n squared is m minus n times m minus n. I couldn't factor this. I couldn't factor this, but m squared minus mn, I can factor out an m. M squared divided by m is just m. Negative mn divided by m is just a negative n. So the factored form of m squared minus mn is m times m minus n. I'm just coughing so that I give you time to think about what you would now cancel, right? So now I have, you don't need to rewrite it. You can just cancel at that point. But this becomes m times m minus n times m minus n, right? Just rewritten with the m first. Over, on the bottom we have m, we have m minus n, and we have m plus n. Good? Cancel out anything, because they're all being multiplied, cancel out anything that is common to the top and the bottom. I have m minus n over m plus n as my final answer. And remember, you cannot cancel the m, right? Because it's a plus and a minus. You can only cancel things that are actually fully being multiplied by everything else. All right, I'm going to stop.